Good morning, class. We are looking at exam 3 review, chapter 3, differentiation rules, chapter 4, application of differentiations. And here's section 4.1, maximum and minimum values, 4.2, the mean value theorem. So in chapter 4, application of differentiations, we're going to cover 4.1, maximum and minimum values, 4.2, the mean value theorem, how derivatives affect the shape of a graph in dependent form, and L'Hopital's rule, summary of curve sketching for this exam. 4.1, maximum and minimum values, definition, critical point or short CP. A critical number point or point of a function f is a number c such that f prime is 0 or f prime does not exist. DNE short for does not exist. So what is the process? We find f prime of x. We set equal to 0. We answer it. We look at where f prime DNE does not exist. So for example, we want to find the critical numbers for f of x equals x to the power minus 2 ln x. And to do so, we are going to find f prime of x, which means we're going to put a raised dot here. This is negative 2 x to the power of negative 3 times ln x plus ln x gives us 1 over x times x to the power of negative 2. As you can see, this will result in x to the power of negative 3, and we can factor the x to the power of negative 3 from these two pieces. This gives us negative 2 ln x. This gives us positive 1. And we can take this down, make it the denominator x cubed. Now, f prime is 0. A fraction is 0 when the numerator is 0. So minus 2 ln x plus 1 equal to 0. Which means you move the 1, make it negative 1, divide by negative 2, make it 1/2. ln x is 1/2. So x is e to the power of 1/2. Remember the arrow I showed you for the logarithmic property. So think about this. So x is e to the power of 1/2, which is an exact answer. And you keep it as such. F prime doesn't exist. A fraction is undefined, or it doesn't exist if the denominator is 0. But x can't be 0. The reason why, because it's not part of the domain. If you look at f prime of x, x setting equal to 0, that means the denominator is 0. It's not part of the domain of f of x. What is the domain of f of x? Remember, it's ln x over x squared. Ln x, the domain is 0 to infinity. So the domain for f of x, and let's rewrite it as ln x over x squared. The domain is 0 to infinity. So 0 is not part of the domain. That's why. Maximum or minimum points on a curve. Here's the formal definition. Local, also known as relative extreme values. Extrema is the plural of the Latin extremum. A local minimum is the minimum value within some open interval. Local minimum occurs at the point C in an open interval of a to b. In the domain, if f of c is less than or equal to f of x for all x values in the open interval. So this is a local minimum. By the way, extrema refers to the y-coordinate of the function, okay? So when we want to see what is the maximum equal to or minimum, we mean the y-coordinate. A local maximum is the maximum value within some open interval. Local maximum occurs at the point C in an open interval of a to b. in the domain if f of c is larger than or equal to f of x for all x values in the open interval. So that would be a local max. Absolute, also known as global. Extreme values or extrema are either maximum or minimum points on a curve, meaning in the entire domain. So absolute minimum occurs at the point C if f of c is less than or equal to f of x for all x values in the domain. This is absolute mean. And absolute max occurs at the point C if f of c is greater than or equal to f of x for all x values in the domain. So that's an absolute max. What I want to add here is this. We go and look at each and every one of those graphs. This is a local minimum, this is a local max in some open interval. And the reason they are local, there are other points. For example, it's a local minimum, other points having a smaller y coordinate. Local mean, local max. Now this one, local mean, local max, local mean. This local mean is also an absolute minimum. Why? Because there is no other point having a smaller y coordinate. Local max, local mean, local max. This local max is also considered the absolute max. No other point is having a larger y coordinate than this point. Find the absolute max and mean value of f on the given interval where f of x is given as 1/3 x cubed minus 9x. The interval is closed interval of -6 to 0. So here's the extreme value, also known as closed interval theorem. If f is continuous over a closed interval of a to b, then f has a maximum and minimum value over that interval. Methodology. Find CPs, which means set f prime of x equal to 0 doesn't exist. Find f of a, f of b, f of c sub 1, f of c sub 2 means evaluate the function, the original function at the end points a and b, as well as all the critical points. Absolute max equals to the largest value, absolute mean is equal to the smallest value. Recall, what is a polynomial function? A polynomial function f of x or q of x is in the form of a sub n x to the power of n plus a sub n minus 1 x to the power of n minus 1 plus all the way to a sub 1x plus a sub 0. This is the constant. This is the leading term. A sub n is the leading coefficient, where leading coefficient can't be 0. N must be a whole number. All of these numbers must be whole numbers. And the domain is all real numbers. This is reminding you of a polynomial function. So what are we looking at here? It's a polynomial of degree 3. Therefore, the domain is negative to positive infinity. When we say the domain is that means it's continuous. Every function is continuous in their entire domain. Therefore, it makes it continuous in the given interval of -6 to 0. So that's the first thing, what type of function we are dealing with. The next step is to find f prime of x. So 1/3 times 3 makes it 1. So x squared minus 9, because we want to set this equal to 0, we are going to factor this into x plus 3x minus 3. And as we set it equal to 0, it results in -3 and +3. We check those to see if they fit in the given interval. Is -3 in between? Yes. Is it 3 in between? No. Also, we want to find f prime does not exist. We did this. F prime does not exist. Doesn't give us any solution. This is phi, which represents an empty set. So this is the Greek letter phi, which represents an empty set in set theory. There are two answers. Only one of them is in the given domain. This, which looks like an epsilon, reads an element of. So we are going to go back to the original function evaluated at the endpoints as well as -3, not both, the one that is in between. So just for the sake of argument, if you plug in -6, you get 1/3 -6 cubed minus 9 times -6. This one you get 1/3 times -3 cubed minus 9 times -3. And this one, I mean, you plug it, obviously you get 0. And you end up with -18, +18, and 0. Here's the largest number. Absolute max is the smallest number, absolute mean. So absolute max equals 18 at this pair. Absolute mean equals -18 at this pair. Absolute max equals 18 at this pair. -3. Absolute mean equals -18 at this pair. -6, -18. So when you answer the question, you want to answer it accordingly, however they ask you to answer. Find the absolute max and mean values of f on the given interval where f of x is x plus 3 to the power of 2/3 minus 5. So what type of a function do we have here? We have a cube root function. In other words, this is the cube root, then you move it to the left by 3, you square it, and then you bring it down by 5, as far as transformation is concerned. Ultimately, any cube root function, there is no restriction. The domain is all real numbers, and therefore, extreme value theorem, closing, f, this function, is a cube root function, which makes it continuous in the interval of negative to positive infinity. Therefore, it's continuous in the given interval of -4 to 5. So that's the first thing we want to establish. The next thing is to find f prime of x. So f prime of x is 2/3 x plus 3 to the power of 2/3 minus 1, which makes it -1/3. The derivative of the inside is 1, so times 1, we don't have to write. To continue with that and get into f prime is 0, f prime doesn't exist, we're going to rewrite this such that this goes down and has now a positive exponent, positive 1/3. So 2/3 times x plus 3 to the power of 1/3. Now, we want to look at f prime equals 0, f prime doesn't exist. So this is a fractional format. A fraction is 0 when the top is 0, it's undefined when the bottom is 0. So a fraction of the form a over b is 0 when a is 0. So when the numerator is 0, the fraction is 0. Over b is undefined when the bottom is 0. So this is 0 when the top is 0, and that gives us no solutions. Why not? Because the numerator is a number. Doesn't matter, positive, negative, small or large. The numerator doesn't involve any variables. F prime does not exist if the denominator is 0. And the denominator is 0 if x is -3. So if you put -3 here, you get 0, right? Now the question is -3 in between the given interval of -4 to 5? The answer is yes. So -3 is an element of the given interval. Therefore, we can evaluate the original function at the endpoints as well as this critical point. So let's see what happens if we want to evaluate it. And it's easier if we just use this one. So if I put -4 here, so if I put -4 here, I get cube root of -1 squared. So let me just write it here. Here. So I get cube root of -1 squared minus 5. As you know, cube root of -1 is -1. Squared, you get +1. 1 minus 5 is -4. F of -3. If I put -3 here, I hope you see that this becomes 0. So that's out. The answer is -5. I don't have to worry about that. That's clearly -5. If I put 5 here, I get 8. If I put 5 here, I get 8. Cube root of 8. Square it. -5. As you know, cube root of 8 is 2. 2 squared is 4 minus 5, -1. So we can easily evaluate those. And so, since they're all negative, the absolute max is -1, the absolute mean is -5. So absolute max is -1 at this pair, absolute minimum is -5 at this pair. That's how we do the writing. Absolute max equals -1 at 5, -1. Sometimes they may want the x coordinate at x equals 5. The absolute mean has a value of -5 at -3, -5. We're going to continue with the same type of question. We're going to find the absolute max and mean value of a function f of x in the given interval. So f of x is x plus 3 to the power of 2/3. Okay, so I got to actually move on with this question. It's a repeat. All right, the next question, we want to find the absolute max and mean value of this function, f of x equals x over x squared plus 2 in the interval of 0 to 4. So, what are we dealing with here? I remind you, it's a rational function. A rational function f is a rational function if f of x equals n of x over d of x, and d of x can't be 0. Where n of x and d of x are polynomials. The domain of f consists of all real numbers except the zeros of the denominator of f of x. Denominator of f of x. Or simply put, denominator d of x. You can think of it that. All right. So if that is the case, let's find out what is the domain here. We set this one equal to 0. And this gives us no solutions because x squared is always positive. Worst case scenario is 0. So x squared plus 2 is always larger than or equal to 2. So x squared plus 2 is always greater than or equal to 2. Therefore, the domain is all real numbers. So extreme value or closed interval theorem, f is a rational function and it's continuous from negative to positive infinity. We showed that's the case because normally that's not the case for all rational functions. And therefore, it makes it continuous in the given interval of 0 to 4. So having said that, we need to find f prime of x using the quotient rule. F prime g minus g prime f over g squared. That's what we are going to use. So f prime of x, the numerator is 1 times the denominator x squared plus 2 minus the denominator gives us 2x, right? We want g prime times the numerator x. And then you write the denominator in a parenthesis and a square. And we're done with calculus as far as I'm concerned. Let's simplify. So this is x squared plus 2 minus 2x squared. We can combine these two into minus x squared. So we have minus x squared plus 2 over x squared plus 2 quantity squared. Now, again, we are dealing with a fractional format. Let me actually clean up the mess here. And f prime is 0 when the numerator is 0. And that means x squared becomes 2x is plus minus square root. F prime does not exist if the denominator is 0. We've already established the denominator without the exponent can't be 0. When you add the exponent, it doesn't change anything. So f prime doesn't exist, does not produce any solution. So there are two solutions, and we know square root of 2 is about 1.41. So is that in between? Yes. How about negative square root of 2? No. Only square root of 2 is in between 0 and 4. So we're going to evaluate this original function at a 0, c square root of 2, and b number 4. Now, I hope you see if you plug in 0, you get 0 over 2. Let's write it actually. 0, you get 0 over 2, which is 0. What happens if you go with square root of 2? With square root of 2, we put square root of 2 at top. Then square root of 2 squared is 2. Square root of 2 squared is 2. Plus 2. You get square root of 2 over 4. With number 4, we get 4 in the numerator. 4 squared, which is 16, plus 2. This is 4 over 18, or 2 over 9. So these are the answers. And I hope you recognize that this is larger than this one. The reason why, if you assume 4 times 2 is almost 9, then what about this one times 2? If you multiply this one down times 2, 1.4 gives you 2.8. So this is large. In any event, maximum, absolute max is this number at this pair, and 0 is the smallest number at 0, 0. So we write absolute max square root of 2 over 4, which is almost 0.35, at square root of 2, comma, square root of 2 over 4, and absolute min is 0 at 0, comma, 0. By the way, this is precisely 0.2 bar, just in case anybody is interested. We're going to continue with the same type of question. We want to find the absolute max and mean in the given interval. In this case, f of x is x squared minus 1 quantity squared. The interval is minus 1 to 2. I hope you recognize this is a polynomial, and the degree is the product of these two numbers, 2 times 3. Polynomial of degree 6, the domain is all real numbers. Polynomial of degree 6, the domain is all real numbers. Therefore, it's continuous in the given interval of minus 1 to 2. So what we do, we are going to find f prime of x using the extended power rule or the chain rule. So f prime of x would be 3 times x squared minus 1 to the power of 2 by the chain rule times the derivative of the inside. The derivative of the parentheses is 2x. And we put the 2x next to 3. We get 6x times x squared minus 1 quantity squared. If we set this equal to 0, it gives us 0 here, and this gives us plus minus 1. I hope everybody can handle this easily. X squared minus 1 is 0, gives us plus minus 1. So we have 3 answers. And f prime doesn't exist, doesn't give us anything because itself is a polynomial. By the way, this is a polynomial of degree 5 plus 2 squared, 2 times 2 is 4, plus 1 is 5, just in case. So you have to evaluate the original function at whatever you can. These are the 2 endpoints. So negative 1 is one of them, no worries. Is positive 1 in between? Yes. Is 0 in between? Yes. So let's evaluate. Negative 1 is considered one of the endpoints. 2 is considered is another endpoint. 0 is a critical point, and 1 is a critical point. By the way, negative 1 is both a critical point as well as an endpoint. So basically, you plug in. If you put negative 1 here, I hope you realize that you get 1. 1 minus 1 is 0, so that results in 0. In fact, 1 squared minus 1, this will result in 0 too. What about 0? If you put 0 here, you get negative 1 cubed. Maybe I write that. So if you put 0, you get negative 1 cubed. If you put minus 1, you get 0 cubed. If you put 1, you get 0 cubed. If you put 2, if you put 2 here, let me use a red color, then you get 4 minus 1, you get 3 cubed. So you put 2, you get 2 squared, 4 minus 1, 3 cubed. So this is 0, this is 0, this is minus 1, and this is 27. So clearly, this is the largest, this is the smallest. So we're going to write absolute max is equal to 27 at the pair 2, 27. Absolute mean is negative 1 at the pair 0, negative 1. Section 4.2 is called the mean value theorem. We're going to discuss Rolle's theorem. Let f be a function that satisfies number 1, f is a continuous on a closed interval of a to b. Number 2, f is differentiable on the open interval of a to b. Then and f of a must be equal to f of b. The end points have equal values. Then there is a number c in the interval of a to b such that f prime is 0. And as you can see, graphs of some typical functions that satisfy the 3 hypotheses are given here. If you have a horizontal line, if you have a curve somewhere in between, the bottom line is there is a tangent line. Because of this, actually, there is a tangent line that has a slope. 0. That's the idea. In this case, we have this one. In this case, we have this one. In this case, we have two possibilities. In each case, it appears that there is at least one point with coordinates c comma f of c, c comma f of c, okay? At least one. On the graph where the tangent is horizontal and therefore f prime becomes 0. That's the idea of a Rolle's theorem. Let f of x be x to the power of 4 minus 2x squared. Find all c in the interval of -2 to 2 such that f prime equals 0. Rolle's theorem has three parts. F is continuous, f is differentiable in the interval, and f of a equals f of b. We know this is a polynomial of degree 4. Polynomial of degree 4. Therefore, it makes it continuous and differentiable everywhere from negative to positive infinity. Therefore, it's continuous in the closed interval of -2 to 2 and differentiable in the open interval of -2 to 2. Why is that? It's a polynomial. So what about f of a and f of b? Let's evaluate them. Here's a, here's b. Let's evaluate f of -2. Let's evaluate f of +2. Now, f of -2, if I put -2 to the power of 4, minus 2 times -2 squared, I get 16 minus 8, which is 8. And f of 2 equals a2 because f of 2 is 2 to the power of 4 minus 2 times 2 squared, which is 16 minus 8. So let's go back and recap. We showed that it's continuous. We showed that in a closed interval of a to b. We showed that f is differentiable in the open interval of a to b, which was -2 and 2. We showed f of a equals f of b. In other words, f of -2 equals f of 2 equals 8. You have to show that. Therefore, according to the Rolle's theorem, this means there exists a c that is an element of a and b such that f prime of c equal to 0. How do we find that? Well, let's find f prime of x and set it equal to 0. Now, f prime of x is 4x cubed minus 4x. We set it equal to 0. Remember, this theorem indicates there's at least one. There may be more, but at least we must have one. So we can factor out the 4x. We get 4x times x squared minus 1. By now, everybody knows this gives you 0. X squared minus 1 is 0, gives you plus minus 1. So there are three answers. -1, 0, 1, and all of them happen to be in between the given interval. So all of them are fine. Thus, in the interval of -2 to 2, the derivative is 0 at each of these three x values. Now, to give you a better perspective, let's look at, this is a polynomial of degree 4. Let's look at the graph, which looks like this, and remember the end behavior and so forth. So at this point, -2, we have 8. At this point 2, we also have 8. At this point, namely -1, at this point, namely 0, at this point, namely 1. Look at what we have. Here's the lines. This is the tangent line, which is horizontal with a slope 0, and this is another tangent line. So at x equals -1, x equals 0, and x equals 1, we have tangent lines that are horizontal. Therefore, it makes f prime at those points 0, f prime of -1, f prime of 0, as well as f prime of 1, they're all 0. The mean value theorem. Now, what is the difference between the two? Let f be a function that satisfies number one, f is continuous on the closed interval of a to b. Number two, f is differentiable on the open interval of a to b. Up to now, it's the same as Rolle's theorem. And then there is a number c in the interval of a to b, such that f prime of c equals f of b minus f of a over b minus a. Let's see the meaning of that, and therefore the difference between this and the Rolle's theorem. The meaning is this. Here's some curve, and here's the 2 points. We connect them. Let's call them A and B. Let's connect them. This line that connects the 2 points on a curve has a name, is called secant line. This line is called the secant line. There is a line which is tangent to this curve because it is continuous and it is differentiable. Somewhere between A and B, we can find a line that is parallel to this secant line. Therefore, it must have the same slope, which is this point. We are looking to find this point, C. So this is A f of A. This is B f of B. And so f of B minus f of A over B minus A represents slope of a secant line. In other words, there is a point P where the tangent line is parallel to the secant line AB. So here's the mean value theorem. Number one, f is continuous on the closed interval of A to B. Number two, f is differentiable on the same interval but open interval of A to B. Then there is a number C in the interval of A to B such that f prime of C is f of B minus f of A over B minus A. This, if you do the cross product, becomes f of B minus f of A is equal to f prime of C times B minus A. So this one and this one are equivalent. So what does it mean? It means the Rolle's theorem is a special case of the mean value theorem. What is so special about that? Remember, if you go back to the Rolle's theorem, it has the third case where f of B equals f of A. So imagine f of B equals f of A. What happens to f prime at C? Becomes 0. And if f prime is 0, that means a horizontal tangent line. So Rolle's theorem is a special case of a mean theorem. So let's actually write that for everybody. The Rolle's theorem is a special case of the mean value theorem with the added hypothesis that f of A and B must be identical. The mean value theorem. Given f of x equals 5 minus 4 over x, find all C in the interval of 1 to 4 such that the slope of the secant line equals the slope of the tangent line. Let's quickly look at the graph of this function. You can even use a graphing calculator. So in the interval of 1 to 4, from here to here, we have this point at 1, this point at 4. And if we connect them, we are saying here's the secant line. Okay. What is the slope of the secant line? We're going to find out, but it has to be somewhere in between such that the tangent line is parallel to that. So we are looking for this point having some x coordinate. That's what we are really looking for. Okay, everybody. So what is this function? This is a rational function. A rational function. What is the domain? All real numbers except x equal to 0. Notice x can't be 0. So for any rational number, you set the denominator equal to 0 and you exclude it. Therefore, this function is continuous in its entire domain. What is the entire domain? Negative infinity to 0, union 0 to infinity. And because 1 and 4 sits in this within the domain, therefore this function, this rational function f of x equals 5 minus 4 over x, is continuous in the closed interval of 1 to 4, because 1 to 4 is actually here between 0 and infinity. So one more time, how did we find the domain for this function? We set x equal to 0 and we exclude that, minus infinity to 0, union 0 to infinity. So it is continuous in the closed interval, and it makes it differentiable in the open interval of 1 to 4. There is no restriction. We know how to differentiate that. So now, if that is the case, there must be some point such that f prime of c equals f of b minus f of a over b minus a. Therefore, we are going to find f prime of c with this, and then we set f prime of x equal to that to find the point. So f prime of c, according to this, is f of 4 minus f of 1 over 4 minus 1. Now, if I plug in 4 here, I hope you see that. If I plug in 4 here, this becomes 1. 5 minus 1 is 4. If I plug in 1, it becomes 4. 5 minus 4 is 1. So 4 minus 1 over 4 minus 1 equals 1. So the slope for the secant line is what? 1. How do we know that? We have 2 points. We calculated the slope rise over 1. Therefore, we take the derivative and set it equal to that in order to find the x. So what is f prime of x? This goes away. Let me just do this quickly. So I'm going to write f of x is 5 minus 4 x to the power minus 1. So f prime is minus 4 times minus 1 x to the power minus 2, which makes it positive 4 over x squared. We are going to set this equal to what we found here. Set this to equal. So x squared becomes 4 and x becomes plus minus 2. So there are two answers. X equals negative 2, x equals positive 2. What is the interval? 1 to 4. So only positive 2 is an acceptable answer. So at x equals 2, we can find a tangent line that is parallel to the secant line. And if you want to find the y coordinate for this point, you have to put it back into the original one. And c or x is 2. So if you put it here, This becomes minus 4/2 is minus 2. 5 minus 2 is 3. So this point has coordinates 2, 3. Let me, in fact, write that. So 2 comma 3, because we put the 2 back into the original function. We're going to continue with the mean value theorem. Suppose that f prime of x is between 3 and 5 inclusively. That means 3 less than or equal to f prime less than or equal to 5 for all x. Show that f of 8 minus f of 2 is between 18 and 30. So 18 is less than or equal to f of 8 minus f of 2, less than or equal to 30. And bear in mind again, when we go look at the mean value theorem, this is equivalent to this one. So we notice that this part looks like f of b minus f of a. So with that being the case, a must be 2, b must be 8. So the interval of 2 to 8. Now, can we use the mean value theorem? Can we claim f is continuous in the closed interval of 2 to 8? Can we claim f is differentiable in the open interval of 2 to 8? The answer is yes. How do we know that? Suppose that f prime of x is between 3 and 5 for all x. This statement is given. That means the function is always differentiable. So if it's always differentiable, it's differentiable in this interval, and it makes it continuous as well. Differentiability means continuity as well. Sometimes the function may be continuous, but not differentiable, for example, if you have a sharp corner, okay? Therefore, the mean value theorem applies. So let's write what we had here, okay? We know f prime of x is between 3 and 5, inclusively for all x. So if that is the case, this is also true. This must be between 3 and 5 because it's at some point. So f prime of c, or f of b minus f of a over b minus a. And we said that a is 2, b is 8. So let's replace the a with 2, b with 8 in this fraction. As you know, 8 minus 2 is 6. Let's multiply all three sides by number 6. So this becomes 18, this becomes 30, and this denominator goes away. And that's the proof, everybody. We just proved using the mean value theorem that if f prime of x is between 3 and 5, inclusively for all x, then f of 8 minus f of 2 is between 18 and 30, inclusively.